Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. File System Hierarchy Standard is the name of this episode. And once again, Don Pizzetta is here to show us the way. Don, good to see you. Nice to work with you again.
Yep, glad to be here. And, we're going to tackle a pretty neat topic here, which is that File System Hierarchy Standard. Many of you, as you learn Linux, have probably experienced where you browse to the hard drive and you see all these crazy folders. Folders that oftentimes just have the three-letter names that don't make a whole lot of sense. And that's a pretty big obstacle to getting in and learning a new operating system. So what we're going to do right here is we're going to take a look at the File System Hierarchy Standard and see what exactly are those folders? What do they do? What is their purpose? How are they arranged? How it varies from distro to distro, and get a little bit more familiarity with that file system. If you're coming from something like Windows, well, you just have a couple of folders that it uses. Inside of Linux, though, there's actually a lot of different folders, and we need to be familiar with them. It'll help you better use the system, but it will also help you with troubleshooting and locating configuration. So definitely a good skill to have, and that's what we're going to be learning about right here in this episode.
So, Don, who created the FHS?
All right, so the FHS has actually been around a long time, right? And that's easier to say than File System Hierarchy Standard, I guess. Which, oddly enough, file systems
I can barely say that.
File system's actually two words, right? File and system.
Yeah.
But in the standard, they decided to combine them, which is not dictionary correct, but they did. So it is the FHS. And basically what happened is, remember that a lot of the Linux stuff that we work with came from the Unix world. So back in the 1970s at AT&T Bell Labs, they created the Unix operating system, and they had to use a file system to identify practically everything. Even hardware was represented as files. Well, it was just a couple of guys, and they were making the stuff up as they went. Well, fast forward to today, where you've got Linux and FreeBSD and OpenBSD and all these different platforms that are all reliant on that same file system structure. How are you supposed to create applications that are compatible from one distro to another if you don't even know where the files are supposed to go? So they teamed up at one point, this was decades ago now, and came up with a standard that said, here's the folders that are the locations that we expect things to be in order for your system to work. And by making consistency, that helps with compatibility. With Linux, anybody can go out there. So you right now, if you want, could go and take the Linux kernel source code and grab some GNU utilities or any other number of utilities that are out there and package them together and create your own distro. And you can map the file system however you want. You can create files with whatever name you want, folders with whatever name you want, put configurations wherever you want. You have that flexibility. It's free, right? But if you're expecting third-party applications to run, they're expecting to see certain folders. And that's where we ended up where we are today, where we have a standard. And the standard was put together, I kind of got off tangent. So going back to your question, who created this thing? It actually came from the Linux Foundation. And we've talked briefly about the Linux Foundation. I think I've got their webpage pulled up here. The Linux Foundation is an organization that is, or was, headed up by Linus Torvalds himself. So, obviously the creator of the Linux kernel is going to be involved here. But it's actually got members from a number of organizations. Companies like Red Hat and Canonical are a part of it. The individuals that create projects like Slackware and other things, they're all a part of it. And so it was a group effort amongst all the major distros at the time to come up with this standard. And it's not like they were really inventing the standard. Most of it just came from Unix, and everybody just agreed, hey, from now on, we're going to follow this standard. So when I log into a Red Hat Enterprise Linux box, I can expect /etc to be there, and I can expect configuration files to be in that folder. And then when I go to an Ubuntu box, I can expect /etc to be there and configuration files to be there. And even if I jump outside of Linux and I go to a BSD system, I can still expect /etc to be there and that it's going to have configuration files because that's what was agreed upon. So the Linux Foundation, they're the ones who put this all together. Almost everybody adheres to it, so it works out pretty well, but it does really kind of come from Linus Torvalds himself as part of his leadership in the Linux Foundation.
Well, Don, where can we view the official standard?
So they do publish the standard. It's online in what is a spectacularly old webpage. This is it right here. So
It does look a bit old.
if you want to look at it, I'll put the link in the show notes,
Yeah.
but it's pathname.com, pathname.com, pathname.com/FHS. That'll take you right here to this amazing webpage, which is pretty neat. What's really neat about it is how static it's been. It hasn't changed much. And I can see right here, the current version is 2.3, which was announced January 29th, 2004, which means as of the filming of this episode, that was 15 years ago, there has not been a change to the FHS in 15 years. That's a long time. And right on here, you can actually come through and view the standard. They have it in PDF, raw text, and also HTML, which is probably the easiest. And if you browse into that, you'll see the actual standard laid out right here. And they're basically defining all the different folders, defining which ones are required, which ones are optional, and what role that folder is supposed to serve. What is it supposed to do? And you can kind of see that here, like /dev is supposed to contain device files, or /etc is supposed to have host-specific system configuration. And if you drill into it a little more deeply, we can come in and find specific options about it, variations, types of files that might be expected to be found in there. In earlier episodes, we've seen files like the passwd file. So right here, it's defined. The FHS doesn't just define folders, it also defines individual files that are inside of it. And so if you've ever found yourself like scratching your head, why is the passwd file, why is it the same everywhere? It's because it's right here. It's part of the standard. Everybody adheres to that. And you can kind of browse through and see it. It's all freely posted right there online.
Do all Linux distributions adhere to the FHS?
You know,
I'm going to say that right eventually.
They-
FHS. Thank you.
they should, but as is the case with most technologies, they don't all do it. Most vendors are actually really good about it. So I mentioned Ubuntu, or Canonical, and Red Hat. Those are kind of the two biggest commercial players in the Linux world. They adhere to it pretty well, but they both deviate a little ways. In fact, I'm not sure I could name a Linux distro that completely conforms to the standard, because there's some weird stuff in the standard that maybe was relevant back in 2004 and today is not so relevant. So especially when it comes to security, there's some things that have changed there, and then the way that we need to lay things out. So when I talk about variations, let me give you an example. I don't know if I can find this real quick in the standard, but there's a folder /sbin. And here, they define it right here for system binaries. Okay, so the /sbin folder, it's got, well, system binaries. Great.
Mhm.
Well, we also have a /usr/sbin, right? Which is under /usr. So here we've got the /usr hierarchy under section 4, and you can find /usr/sbin in the list there. Non-essential standard system libraries. So both folders have system libraries, but one folder is for essential stuff and one is non-essential. Well, why do we need to separate those out? Now, in the old days, there was a case for that. Hard drive space was at a premium. Maybe you're allocating out partition spaces to say, I've got this much space for sbin and this much more space for /user/sbin or whatever. There was a use case for that. But today, storage is cheap. You know, we don't necessarily need separate partitions. And so a lot of distros have started combining those. And, you know, I'm on a CentOS system. Let me show you here. This would be the same. I believe Ubuntu is doing the same today, so you should be the same on either one. But if I navigate in my CentOS box, I can go to cd/sbin, right? And I can take a look inside of there, and I see a bunch of executables, right? So here's these system binaries and libraries. So there it is. And then I can go into /usr/sbin, and I can take a look, and I see a bunch of files and binaries. If you're a sharp observer, you might notice that they're the same, right? I'm seeing the same files in both folder, and that's because /usr/sbin is a real folder. If I pull up the full listing here, see how I've got sbin, and it's flagged as a directory right there. It's a real folder. But if I take a look at /sbin, it's a link. It's a symlink. So what happened is the CentOS team, really Red Hat and the RHEL team, they made the decision that there really wasn't a need to separate these out. It just creates confusion. So they combined everything into /usr/sbin, and then they just symlinked sbin. And that's important to note. They symlinked it. They said it is still important to have /sbin because many applications expect that. but we're not going to maintain separate files anymore. We're going to go ahead and combine it. And you'll see that, like up here, I've got /bin, same kind of thing, /lib/lib64, where if a vendor decides to deviate from the standard, they normally put symlinks in place so that they still technically conform to the standard, even though the files are in a different location. So if you learn the standard, you'll be pretty safe. If I'm navigating my file system and I go to /sbin, not /usr/sbin, thanks to that symlink, I still find everything that I want. I can still use the system the way that I expect. So it's pretty rare that somebody will deviate from the standard and not put symlinks in place to preserve that compatibility. It's pretty rare for somebody to step in and say, I don't care about compatibility. And that usually only happens on really, really specialized distributions, things like pfSense, right? That's, well, technically that's BSD, not Linux. But anyhow, it's specialized for firewalls. And they say, we don't need compatibility. You're not loading other applications. It's just going to run what we've put on there. And so those are scenarios where they might deviate. But most people do conform to the standard.
Well, Don, where would we normally find applications?
All right, so our applications that we run, right? I just actually showed two examples right there, /bin, or sorry, /sbin and /usr/sbin. But applications can actually come from a number of places. There's really, I'd say 5 locations by default, but you can put an application wherever you want. And when you install an application, it can go anywhere. It can end up all over the place. That makes it hard to find. And that's why in an earlier episode, we learned about some commands to be able to locate applications. But for example, if I go into my root folder here, there's a couple of folders that are really designed to be able to store those applications. And let me zoom in a little bit here. All right, the first one is /bin, right? /bin is short for binaries, right? And applications are typically binary files that we flag as executable, and they can run. So /bin seems like a really great place for those to be.
Yeah.
And then there's the USR, the user variant of it, which is /usr/bin. Same thing for sbin and /usr/sbin. So those are a couple places. But these folders, these aren't where, like if I install OpenOffice, OpenOffice isn't going into /sbin, or at least not normally. So applications that I install, those are considered optional applications, and they will normally go into /opt, the OPT right there. So that's kind of that 5th place. So /bin, /sbin, /user/bin, /user/sbin, and /opt. Now, when you install an application, there's actually a number of vendors that will maybe not put it in /opt, let you pick somewhere, maybe even runs through your home folder. And they may actually create links to their application inside of /user/sbin or somewhere. And that creates that uncertainty of like, where the heck is this app? How am I going to find it? But let me run over the official standard and what these folders are for, right? The first one is that /bin. This one is what's considered essential command line utilities that are available to all users, all right? So this is stuff that is really considered essential for the system to work. And if you were to browse around on a system where these were separated and poke around in there, it's going to be things like systemctl. Well, actually, that'd be an administrative command. That would be an sbin. So there's a little variation there. But commands that are critical just to the regular operation, things like mount, right? In order to mount a file system, I need the mount command. So it would need to be in /bin. /sbin, on the other hand, that stands for system binaries. And system binaries are required for the system to boot up. If it's missing a particular binary, it can't even boot anymore. When the Linux kernel runs, it then needs to fire up the operating system. It needs to perform operations, and it needs a certain set of commands. Those are going to be found inside of /sbin. Then you've got the user one, /usr/bin. That one is going to have the rest of our user commands. User commands that aren't considered essential. We don't have to have them, but they're nice to have. So they end up in /user/bin. And then /user/sbin, those are non-essential system binaries. So they're ones for the system to use, for the kernel to use, really, but they're not essential. The system would boot up if those were all missing. Now, those 4 right there really all pertain to system commands, not applications. And that's where we have /opt. That's where we're going to find things like OpenOffice or whatever if we've installed it. In fact, here, let's take a look at mine. So on my system, I know it's symlinked. So if I go to /bin, I'm actually seeing /usr/bin, or really the combination of the two. And if we look around inside of there, we're going to find things like the zip utility if I want to create an archive, right? or I'll probably find gzip in here as well. There's yum to be able to do package updates and operating system updates. I don't know. There's a ton of junk in here. The cat utility and things, and these are all really useful utilities, ones we use all the time, right? But they're not essential. I don't have to have them in order for the system to boot, but I might have to have them in order to perform some kind of operation, right? But it's not like the system depends on them to boot. If I look inside of /sbin, on the other hand, I'm going to see a bunch of things in here that deal with like interacting with the file system, right? Things like fdisk and so on. We'll see other utilities in here, like for interacting with CPU, for printing subsystem, and so on. This is stuff that users aren't normally going to run. Sometimes we might, though. If you watched our storage episodes, we used all these logical volume commands when we were working with the logical volume manager, or LVM. Well, if you look, see how they're all glowing blue? They're not actually here in this folder. They're linked from somewhere else. If I do a -L on that, I can see that, well, actually, most of these are just aliases, aren't they? So they're all just linked to the LVM command, which actually is right here in this folder, so not somewhere else. So some of these aren't even really commands. They're just aliases or shortcuts. The MKFS commands are like that. If we pull up all of those, well, they actually do show up as binaries, mkfs.ext2 and so on. But some of them, like these guys right here, are just aliases off of a base command. So you'll see variations there. If I look in /opt, actually, I don't think I've installed anything on this system. Looks like I got some kind of Red Hat binaries in here. Whoops. And actually, I don't. Yeah, that's an empty little world right here. I haven't installed any applications on this system because we, just installed it for the show. But if I start installing things like OpenOffice and Firefox and so on, if they come from system packages, then they may actually end up in the main binary folders. But if I'm installing them from a third-party site, then they'll typically end up right here inside of /opt. That's that optional software. And I've noticed over the years that Linux distributions are the worst about using this folder. BSD systems are usually the best about always using it, pushing all sorts of things in there. So you'll see variations there. But I guess I've just done a really long answer to your short question, Zach, of where are our apps. Those are kind of the 5 main places where you're going to find the application files.
Well, what are some of the other key folders we need to be familiar with, Don?
All right, there are a lot of other folders in here. And kind of looking at it, actually, you know what? I'm going to use the GUI. I'm going to cheat. I don't normally use the GUI for whatever reason, but let me just browse into the file system here. Here we go. All right, so taking a look at these folders, when you browse into your file system, there's a lot of crazy folders in here, some that are super, mega, insane, important, right? And then there's some that you don't really care about, right? And if you don't know them, if you're not familiar with them, then they don't make a whole lot of sense. So let's just kind of run through some of the critical ones. If you read the FHS standard, there's actually something like 50 folders that are defined. You don't need to know them all for the exam. You don't even need to know them all for real life. There's really just a handful that we deal with on a regular basis. Probably the most important one is this guy right here, boot, right? The boot folder, it's almost always a separate partition. And so this is more of a mount point than a folder. And that's because it contains the Linux kernel and other files that are basically fired up first. When your system boots up in the very beginning, this folder gets called. If you're doing disk encryption, you can't encrypt the boot folder because otherwise you wouldn't be able to read your boot files. So this will be a separate partition that's unencrypted. It could be combined on a single partition, but it causes problems with things like Lux disk encryption. So that's the boot folder. And if you ever browse into it, you'll see things in there, basic configuration files. You'll see some stuff about VM linas. That's the actual kernel file right there. That's the first thing that gets run. And I've got grub, that's my bootloader that helps it find the partitions with the operating system. EFI, that's for my UEFI BIOS, so that it's able to locate and boot the operating system. So all really critical stuff, and that's found in /boot. Now, you rarely mess with what's in /boot. In fact, on a lot of distros, this will be mounted read-only because you don't want somebody messing with the kernel on the disk, and so it's kind of flagged that way. It depends. Yours may or may not be flagged read-only, and you can always mount it read-write, and that's what happens when you do an update or you need to change your bootloader. It'll have to get mounted that way. There's /dev, which is short for device, and this is where all of our device definitions go. In Linux, every piece of hardware is represented as a file. And if you watched our storage episodes, we saw that with hard drives. All of our hard drives were /dev/SDA1 or /dev/ logical mapper / whatever. It doesn't just stop with hard drives. You'll see that with your console, your displays, your video card, printers, all sorts of things will show up in here as a device file. And so that's kind of what I'm looking at here on this screen is that big list of files for all these different devices. And if it's not in here, then that means your system doesn't know about that piece of hardware. You're probably missing a driver or something else that's critical to make that work. So kind of an important folder when it comes to troubleshooting hardware. Also an important folder if you're trying to mount a partition, you'll find the name right inside of here. All right, let me go back up. Let's see, that was /dev/etc. That one's super important, right? This is where our system's configuration files will go. And we've gone into this folder in a number of episodes already, and we'll continue to go into it for some other ones. But basically, when you fire up a service or an application, it needs to know a configuration. And that configuration is expected to be stored here. It's mostly just packed full of text files. So it's not a very big folder. But those text files are really important because it's telling your system how to configure itself. /home, that's where your user home folders go. So all your personal files. And this will oftentimes be a separate partition as well, so that if we fill it up, it doesn't mess with the regular OS. It still has room. But it doesn't have to be. In fact, I think on my system, it is actually part of my main partition. But anyhow, that's where your user stuff will go. /lib, those are for libraries or linkable libraries. When applications run, they rely on libraries to provide basic functions, and they're usually shared between applications, and so you'll find those in that. I'm on a 64-bit system, so I also have lib64. When Linux was created, it was all created around a 32-bit ecosystem, and so when you see a folder like lib, it's expecting 32-bit libraries to be in there. Let's see, some other ones. MNT. MNT is an optional one. You might not have it. It's short for mount. In the olden days, when we would mount a hard drive or a CD drive or whatever, we would mount it to a folder under MNT. A lot of distros don't do that anymore. The ones that do auto mount will usually mount it under the run folder. And I see I've got run also. Run is not in the FHS, not in the official standard. It's just something they made up, but it's there. And it just shows you can choose to deviate if you want to. Let's see, /proc. Whoops, I'm going to break my system. /proc is a really neat one because this looks like a folder. Actually isn't, right? This is a virtual file system. Every program that you run is a process. And the process is represented as a file inside of /proc. So it looks like you're navigating around it. In fact, let me go back here. If I go into /proc and pull up a listing, I see all these numbers, right? What are those numbers? Well, if I were to pull up a list of applications that are running on my system, I see all of these process ID numbers right here. That's the process ID of that binary running in RAM. Well, in the file system, that all gets represented right here as files. And you can even browse inside of them. So if I pick one at random, like 10971, and pull up in there, I can start to find out information about that application that's running. These are not real files. This is all virtual. It's being dynamically generated as I navigate through. And it's part of that whole idea of representing everything as a file. Not everything in Linux is represented as a file. There's an operating system called Plan 9 where they went hardcore and everything, literally everything, is represented as a file. In Linux, most everything is represented as a file. And so that's kind of what we see in /proc. Similar to that, /sys. If you go into /sys, this one is not showing me information about processes, but showing me information about the system, the Linux kernel and what it's running. And so you'll see things like device detection. If you're running a hypervisor, kernel data, that's all tucked away in here. And so when you run something like uname-a to find out what kernel you're running and the version, that's actually coming from inside of /sys. It's looking in there to find it and represent that, put it on your screen. I already talked about /usr a little bit for /usr/bin and /usr/sbin. This one is supposed to contain our really binaries and any other kind of data that's designed to be shared between users. And I don't mean shared across the network. I mean shared between users right here on the system. If there's a library file and I have a user account, Zach has a user account, there's no point in storing 2 copies of that library. We can put it in /usr, and now we both have access to it. So that was the original intent of /usr. On servers, that makes a lot of sense. On desktops, it doesn't. And so it really just kind of became the de facto dumping grounds for everything. Everything is considered to be shared amongst users these days. And that's why you're seeing more and more distros linking to the /usr folder. But if you look, there's more than binaries in there. There's libraries. So I see lib and lib64. You might have an etc folder here for shared configurations, source folder, games. If you've installed games, I didn't think I had, but apparently, oh, it's empty. All right, so so I don't have anything on there. But these are things that every user would then have access to inside of /USR. Neat little fact here: this is supposed to be mounted read only based on the FHS. That way, users can't tamper with binaries that other users might be accessing. Very few distros actually mount this read-only today, though, so this is another area where a lot of people deviate from the standard. And another important folder for us, let's see, that was /USR, is VAR, that one, which is just short for various, and this is a various folder, but it's not too much variety. There's actually a couple of things we expect to be in there. First off, our log files. Log files for our applications, for the system, for Journal D, for all these other different things. Those log files get dumped into /var/log, but also our print spooler, right? When we print a job, it gets written to the hard disk first before being sent to this printer. And so that's inside of /var/spool. And if you poke around in there, you'll find a lot of things like there's spool, like I mentioned, and log is right above it. But you'll see other things. If you're running an email server, your mail queues will be in there. The point about /var is that it's supposed to be considered temporary. The stuff that's in there isn't supposed to be mission critical. If I lose my logs, the system's actually fine. I'll be okay. If I lose my print spool, it's fine. I'll be okay. If I lose email in transit, that kind of thing. It's not really critical. It's just temporary. And in the older days, you'd put your cheaper storage in /var because you didn't care about it as much. Today, storage is so cheap and so reliable that /var is usually pretty stable. And so people will put things like security logs in there that they intend on keeping long term, even though that's not the original intent of the folder.
Don, do we really need to have all these folders memorized, the ones you just went over?
Yeah. So for the exam, yes. Yeah, you do. At least the ones that I named off, right? Don't go and memorize the whole FHS. That's crazy. The ones that I just highlighted, those are kind of the critical ones. You want to know those for the exam. In real life land, you can actually cheat a good bit. If you don't remember these folders, it'd be fine because it's so easy to find files. In fact, we have a whole nother episode coming up on how to locate stuff in Linux. But just to kind of do a preview of that, let me get to a console here. So let's say I want to find a file. Yeah, I'm going to be using the what would be a good one, like the SSH command, right? I'm going to SSH into a server, and I want to make sure that SSH is a certain version, and so I need to take a look at the SSH file itself and test it. Well, where is it stored? I might have to think to myself, all right, well, is that an essential binary or is it non-essential? Is it in /bin/sbin /usr/bin? It can be any number of places. Or is it in /opt? Has it been overridden? Where's it at? And so you can use commands like which. And the which command, if you say which followed by a binary, it's going to figure out which actual binary would be run if I typed that command. And so it tells me this one is /usr/bin/ssh. Now, there could be more than one copy of SSH, though. And so we can use a different command, which is where is SSH? And then it's going to find if there's multiple copies, it'll show me the multiple copies, and even things like the help documentation and the configuration. So it's telling me right here, the binary is /usr/bin/ssh. The configuration is /etc/ssh. And the help documentation is /user/share/man/man1/ssh.1.gz. Rolls right off the tongue. So
it does. It just rolled right off.
We don't have to remember it if we can remember the where is command, right? You can run that into it. There's also locate and find. Locate and find I'll cover in another episode, but they're useful for finding not just binaries, but any file. If I'm just trying to find a file, I forget where I saved it, I can use locate, I can use find. They'll find it, obviously, it's in the name, or locate it, and then we can get that. So if you don't have it memorized, you'll get by just fine in most scenarios, but it takes time. If you have it memorized and you know exactly where to go, you save a lot of time and you're more efficient. So that's the way I always look at it when it comes to memorization.
Awesome, Don. File system hierarchy standard. And this is another great episode, FHS, if you please. And Don, before we move on, anything else you'd like to say?
This is all fairly static. It doesn't change very much. And I know this is our Linux Plus show, but if you learn the file system hierarchy standard, when you jump over to like Macs that run Mac OS, they actually conform to a lot of this. And if you jump over to BSD, a lot of them conform to this too. So you learn it once, but it applies to more than one operating system. That's a pretty cool thing. So definitely spend some time and get familiar with it.
Great advice. Thank you, Don. And a great episode as usual. CompTIA Linux Plus is a wonderful series, and it's designed to help you. So make sure you watch every single episode. You'll be glad you did. And don't forget about our course library, where there's supplementary information that's there to do one thing, help you go even further. So check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.